Hi, I am a tutor in Uplatz. Today we are going to discuss about MATLAB Coding Guidelines Part 1. The first, avoid causing confusion, avoid doing things that would be an unpleasant surprise to the other software developers. The interfaces and the behavior exhibited by your software must be predictable and consistent. If they are not, then documentation must clearly identify and justify any unusual instances of use or behavior. To minimize the changes that anyone would encounter something surprising in your software, you should emphasize the following characteristics in its design, implementation, packaging, and documentation. Simplicity, meet the expectations of your users with simple functions, classes, and methods. Clarity, ensure that each variable, function, class, and method has a clear purpose. Completeness, provide at least the minimum functionality that any reasonable user would expect to find and use. Consistency, design similar entities with a similar look and behavior. Create and apply consistent standards whenever possible. Robustness, provide predictable documented behavior in response to errors and exceptions. Do not hide errors and do not force users to detect errors. Avoid throwaway code. Apply these rules to any code you write, not just code destined for production. All too often, some piece of prototype or experimental code will make its way into a finished product. Even if your code never makes it into production, someone else may still have to read it. Anyone who must look at your code will appreciate your professionalism and foresight at having applied consistent rules from the start. That person may well be you, looking at the code, trying to figure it out long after you wrote it. Help the reader. People who read your code are not passive. They actively try to interpret and organize it in their rights. You can help the reader by making your naming consistent with meaning and by using layout consistent with logical organizations and by supplying additional relevant information. You may well be that reader even while writing the code. Maintain the style of the original. When modifying existing software that works, your changes should usually follow the style of the original code. Do not attempt to rewrite the old software just to make it watch a new style. Rewriting an old code simply to change its style may result in the introduction of costly yet avoidable defects. The use of different styles within a single source file produces code that is more difficult to read and comprehend. And if the existing style is problematic, then consider changing the style of the entire file to make it consistent. Use of smart indent to clarify structure through layout is relatively safe. Carefully changing the comments about compatibility with the browser is also worth considering. If you make changes, then be sure to run regression tests and any existing software that interacts with the module. Document the style deviations. No standard is perfect and no standard is universally applicable. Sometimes you will find yourself in a situation where you need to deviate from an established standard. If so, then strive for clarity and consistency. Before you decide to ignore a rule, you should first make sure you understand why the rule exists and what the consequences are if the rule is not applied. If you decide you must violate a rule, then document why you have done so. Some organizations will have reasons to deviate from some of these guidelines, but most organizations will benefit from adopting written style guidelines. Keep content within the first 80 columns. Avoid writing codes in long lines. Short lines are easier to read than long ones. In general, the readability of text decreases as column width increases. The recommended 80 column width is a common dimension for editors, terminal imitators, printers, and debuggers. Readability improves if unintentional line breaks and horizontal scrolling are avoided when parsing a file between the programmers. Limiting the lines to 80 columns will make side-by-side viewing in two windows easier. Split long code lines at graceful points. A long line is one that exceeds the suggested 80 column limit. If you have two or more statements on one line, then write each on a line of its own. If a line is too long because it contains a complicated expression, then rewrite the code to make one or more sub-expressions on separate lines. Give the sub-expressions meaningful names. Keep parenthetical elements together if possible. Split long line codes at this point. The statement if is should be replaced by something like value present as shown in the figure. If the lines is still too long, then wrap it at a point that is mostly readable. In general, break after a comma, right parenthesis, string terminator or space, for example. This command, all values above dot 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 int or to a string threshold and are discarded. If the line is too long, then wrap up to the an operator. So the operator is wrapped. Indent statement groups 3 or 4 spaces. Good indentation is probably the single best way to reveal program structure. It can set up groups of statements from formatting another code. It can also clarify the beginning and the end of loops or conditional statements. Indentation of one space is too small to be clearly visible, so indentation of 2 spaces is sometimes suggested to reduce the number of line breaks required to stay within 80 columns or nested statements. However, 2-character indentation is marginally visible, and in any case, MATLAB code is usually not deeply nested. Indented statement groups 3 or 4 spaces. Indentation larger than 4 spaces can make nested code difficult to read because it increases the chance that the lines must be split. Indentation of 4 spaces is the current default in MATLAB editor. There was the default in some previous versions. Do not rely on counting spaces for indentation. Establish your standard in the editor preference menu. Match both tabs space and indent state setting to achieve consistent display. Indent consistently with MATLAB editor. The MATLAB editor automatically provides indentation that clarifies code structure and is consistent with most recommended practices for C++ and Java. If you use a different editor, then set it out and your MATLAB editor to produce consistent indenting so that you can easily transfer code. Indentation problems when using the editor usually occur when the code is not written in sequence. For example, the code is inserted with copy and paste or another case is added after a selection construct initially written. Use the smart indent feature in the text menu to provide uniform indentation at the right place. Do not use our tabs. If you use MATLAB editor, then select the option tab key insert spaces in the preference menus. If you use a different editor, then do not rely on odd tabs for indentation. Odd tabs can easily produce different amounts of indentation when displayed in different editors. Put only one executable statement in a line of code. This practice improves readability and allows the JIT and Accelerator to improve performance. Putting multiple statements on one line for conditional constructs or loops lacks an indentation cue for the reader. It may also produce lines that are too long on one line. Conditional constructs also tend to leave out the often most important else code. Put only one executable statement in the line of code as replace the conditional if beta greater than or equal to delta alpha equal to delta end with if beta greater than delta, the next line write alpha is equal to beta and then end. Replace the one with one loop, one line loop for k is equal to 1 is 0 10 by k dot power 2 end with an integer loop for k equal to 1 in values y equal to k dot power 2 end. Define each variable on a separate line. Use one line for multiple definitions, then to produce overcoded expression variable names that are too short and unnecessary little numbers. Replace row 10 column 5 array 0 10 comma 5. Formatting 11 with more readable and more flexible. End rows is equal to 10, end rows columns equal to 5, array is equal to 0, so end rows columns. Use argument alignment if it enhances readability. For example, weighted kids, body weight in boys plus girl weight star and girls. However, this type of alignment can be tedious to establish and maintain. It is not needed to make simple case. This is readable. The lines put button private button 1, 2, 3. Click add to next, click on it. Set text long and split into 2 parts are now no clearer than 2 part but and set text long split line into 2 parts. Use argument element if it enhances readability. We have many expressions aligned in a statement, then this is probably a sign that you should rewrite the statement using intermediate variables. In general, do not align definition statement. Replace x is equal to 3, y is equal to 4, diagonal is equal to 5, x is equal to 12 with x is equal to 3, y is equal to 4, and diagonal is equal to 5. Avoid heavily nested code. Heavily nested code, particularly in or if or switch constraints, should be rewritten to avoid unnecessary scrolling up editor windows. Several practices can be used to reduce the amount of nesting. Straightforward vectorization can sometimes help reduce from loop nesting because most MATLAB programmers are used to doing it. In some cases, use of switch case construct may support less nesting than the use of if else if. The use of cell arrays with case may be more readable than a string of logical expression with else if. It may be helpful to extract some of the nested code into a function or subfunction. Include white spaces. In the white space, the use of blanks or spaces enhances understanding of the code by making the individual components of the statement or expression stand out. It is a major contributor to readability. Surround equal to and or and by spaces. Using space around the assignment character provides a strong visual cue separating the left and right hand side of a statement. Replace simple sum equal to first sum plus second sum without space with sum space equal to first sum plus second sum semicolon. Using space around the binary logical operator can clarify complicated expression. The statement A less than B and then C less than D is easier to visually parse than clogging them without spaces. Use white spaces around operators when it enhances readability. Putting spaces around all operators is controversial. Some programmers find that it enhances readability, others prefer shorter lines. Compare the widely spaced simple average first term plus second term by n term. Scale is equal to 1 n iterations with tight simple average equal to first term plus second term by n term. So scale is equal to 1 is to n iterations with the intermediate. Simple average is equal to first term plus second term by n term. The scale is equal to 1 is to n iteration. Use of white space around operators when it enhances readability. Putting white space around all operators is not as common in MATLAB as it is in some other languages, because MATLAB is a mathematically oriented language and custom is to use less ordinary spacing for generic variables with short names, and in practice, z is equal to x plus y is more common than z space equal to space x space equal to plus space y. Also, putting spaces around all operators can obscure any structure within a compound expression. Replace a space plus b space star space c divided by d space star space x star space minus space g with a plus b star c divided by d star f minus g. Follow commas with the space maintenance readability. These spaces can make code that includes multiple arguments easier to scan. The line foo alpha space, comma space beta comma space gamma is more readable than foo alpha comma beta comma. In contrast, when the identifiers are short, then expression can look better without spaces. Yeah, foo x comma space y can be written as foo x comma y. It is common practice not to include spaces after commas that separate array indices. Do not put spaces before a comma, colon, or semicolon. Insert spaces for multiple commands in one line. Put multiple statements on one line is not recommended. If you choose to do it, then insert spaces to help reader distinguish statements from the expression. Replace if elements greater than one, comma, display yes and end with if n elements greater than one, comma, display yes, comma, end. Do not put spaces just inside parentheses. Do not put spaces immediately after a left or before a right parenthesis, bracket, or brace. Use of this extra spacing is tedious to apply consistently and does not enhance readability. Do not follow function names with a space. MATLAB allows space between a function name and the left parenthesis before its input arguments. When you avoid inserting the space, it is easier to distinguish a function and command forms. To follow a keyword with a space so that it does not work like a function. Do not space out semicolons at the end of the line. Use a column of semicolons to visually define a block. Code is a leftover practice from the days of line printer listing that is no longer needed or desirable. Maintaining the alignment when the code is changed is much more trouble than it is worth. Break code of any appreciable length into blocks. Blocks read like paragraphs and get to read a chunk of the code. Each block should be cohesive, performing a task such as initializing variable, checking parameters, or computing a task. The code lines in the block should be fairly self-contained with well-defined information passing to other blocks. Comments can proceed the code block to summarize its purpose and provide any important explanations. Separate logical groups of statements within a block by one blank line. Enhance readability by introducing vertical white spaces between logical class with a block. Within a block, the use of one blank line gives a sufficient visual clue distinct from multiple blank lines between blocks. Separate major blocks by more than one blank line. You can use 2 or 3 blank lines or sections markup lines. This allows a single blank line within a long code block while still helping the entire block stand out from the adjacent blocks. The number of blank lines can depend on the context. For example, fewer lines are appropriate when followed by a command for the next code block. Do not use the command symbol followed by a repeated character such as star or dash to visually define code blocks. This approach might have been helpful when programs were primarily viewed on a line printer listing. It is no longer as important now that commands are displayed in a different color from the statements in the editor. Blank lines establish enough of a break in an editor window and look better than such ASCII art. Separate subfunctions by more than one blank line. You can use blank lines or section markup command lines. This practice also distinguishes visual breaks between the main function and subfunctions within a file. Use edited cells. Most code will be read in an editor. Use the section markup of edited cells to provide visual separation between code blocks, formatting 17 or subfunctions. In addition to supporting selective execution, cell enhance readability in editor and support publish feature. A cell break or a cell break after a blank line provide enough visual separation to adequately distinguish code blocks. Use meaningful names. Use identifier names that convey a meaning consistent problem domain or a typical interpretation. MATLAB can cope with W is equal to H star N, but the reader will find it much easier to follow. Wage is equal to hourly rate into N hours. The right for descriptive but not overly, but post names, yes, computer years, number of students with salary, year to retirement, number of N students. Meaningful names make the identifier easier to understand and remember. Both attributes make the code easier to read, write, and use. Use familiar names. If your domain convention is to use a client, do not use customer or consumer as a variable name. Put the elements of compound names in familiar order. Replace length term with arm length. If the software is targeted for a knowledge domain or a user group, then use names consistent with standard practices in that domain or by that group. Replace image region for analysis with ROI or region of interest. Use consistent names. Simplify the reader's life by not mixing similar names such as customer data, customer info, or the same related values. Organize the data so that it makes sense to use one name or multiple distinctive names. Similarly, avoid mixing similar action terms such as fetch account, retrieve store, return customer, get inventory for the same general functionality. Avoid excessively long names. Names that are too long can be difficult to scan and use. Long names are particularly problematic in visually parsing expressions because very long names decrease the readability of expressions and statements. The best names are those just long enough to be descriptive. In general, names than 15 characters are not recommended. Replace apply threshold to data array with apply threshold. The goal is in choosing names is not necessarily to give everything complete and proper names, but rather to give them comprehensible and tractable names. Avoid cryptic abbreviations. Make identifiers easy to read by avoiding unnecessary abbreviations or shortening. The use of abbreviations may usually make names less pronounceable and more difficult to remember. Programmers are used to some shortening in compound words, but do not overdo it. Use word word to reduce the ambiguity and help make the code self-documenting because they are often not unique. Abbreviations are prone to interpretation and typing errors. Use computer able time. Avoid CumAR. In this case, it is unclear whether the intent is compute or compare. Common MATLAB usage justifies some abbreviations such as COL for column, DAM for dimension, and H for handle. Domain-specific abbreviations are also acceptable. For example, shuttle for space shuttle, tech for technical, METS for medications. Some abbreviations might benefit from a defining command near their first appearance. Treat familiar acronyms as birds. Domain-specific phrases that are more naturally known through acronyms should be used as acronyms rather than compound words. For example, HTML, CPU, CM use the same convention for capitalization acronyms as for words. Use HTML version PDF parser, not capital HTML version, capital PDF parser, or smallest capital TML version, P small p DF capital parser. Avoid names that differ only by capitalization. Names that differ only by capitalization are easy to confuse, and this is an almost certain way to introduce different consistent capitalization is one of the hallmarks of the code style. Do not use lifetime or lifetime in the same module in which you use apply time. Do not use X, small x and capital X in the same module. Authors of the books and papers sometimes use the names such as small x and capital X together or related but distinct entities. Programmers work in a different context because most readers find it easier to differentiate similar names on the printed page than in code displayed on an edited screen. Avoid names that differ only by one letter. Choose identifier names that will not be confused. Names within a file should differ enough to be readily distinguished. Names that are almost the same make the code difficult to scan. They also increase likelihood of unintentional use. Code written by novices often include names like A1, A2, A3, or AAA. This is usually evidence that the names are not meaningful. Even names that carry some meaning can be problematic if they only differ by one number or letter. The following published code has an error in the third line that is disguised by poor variable naming. Total is equal to price stock quantity. Total 2 is equal to total discount. Total 2 is equal to total into star into 1 plus tax rate. The intent was subtotal is price into quantity. Discounted total is equal to subtotal minus discount. Billable total is equal to discounted total minus star 1 plus tax rate. Avoid names with out to read character sequences. Avoid names containing sequences such as II1 or 0O because they can be difficult to recognize as spelled consistently. Also avoid using lowercase l or uppercase O as a single lettered name. Make names pronounceable when you can. Names that are pronounceable are easier to read and remember. Avoid cues can make names easier to word in a short-term memory. Pronounceable names improve communication with other programmers and also reduce the likelihood of typographic errors. Write names in English. The MATLAB product is written in English and English is a preferred language for international development. Avoid ambiguous or vague names. A good name distinguishes one variable from another. A variable name that has to be deciphered should be changed. Names such as temp1 or pec convey little meaning. If used, they should be limited to very small scope. Be selective with the use of numbers at the end of the names and the appearance of numbers at the end of the variable names. Often indicate poor naming. Replace length and length with length struct length spring or better struct length and spring length. There is at least one code for numbers at the end of the names. They are appropriate for coefficients of equation A1 star x plus A2 star x dot power 2. Name according to meaning, not type. The type or class of a variable is available in the workspace browser, including type or class in a variable name creates a headache if the type or class is changed. Use customer step, not customer structure in each step. Use lowercase for simple variable names. This is a common practice in C++, Java, and Windows communities. For example, use linearity delta. Very short variable names can be in uppercase if they are uppercase in conventional usage and if they are unlikely to become parts of the compound variable name. Example, include capital G and R in electrical engineering and Q in signal processing. Use lowercase camel case for compound variable names. The lower camel case starts each word in a compound name with an uppercase letter except the first word. The use of capital letters makes it easier to recognize the individual words in the variable name. This is common practice in C++, Java, and Windows development communities. Starting variable names with uppercase is usually reserved for objects, types, structures in other languages. Use credible capital threat, quality of life. Use lower camel case for compound variables. Some work to use underscore to separate parts of it. Variable mean. This practice is common in Unix. Although readable, this usage is generally unexpected and not common for variable names in other languages. Another issue with using underscore in variable names used in graph titles, labels, and legends is that A text interpreter in the MATLAB will read underscore as a switch to subscript. So you will need to apply the parameter value pair interpreter none for each text string. Use meaningful names for variables and with a large scope. In practice, most variables should have meaningful name. A descriptive or meaningful name is especially important when a variable is used in code locations that are far apart. This usually eases the reader's burden of remembering what quantity a variable name represents. Names that are too short are a common problem that obscures meaning. That is, it is easier to understand and remember the meaning of a salary than yes. Limit use of very short names to variables with a small scope. The use of short names should be reserved for conditions in which they clarify the structure of the statements are consistent with intended generality. In general purpose function, it may be appropriate to use short generic variable names such as x, y, z, and t. Scratch variables used for temporal storage or indices can have short names because they do not need to be remembered outside the local scope. Variable names in different local scopes also do not need to be unique. A programmer reading such variables names should be able to assume that its value is not used outside a few lines of nearby code. Be consistent with I and j. The letter I and j have long been used as both the many numbers and indices or loop counters. There is an inherent conflict in usage with no solution that will delight everyone. Many code examples in MATLAB and other languages use I and j as a loop counter. Those who favor this usage can establish a different variable for imaginary numbers such as capital J or JAY, or use an expression of the form 1i, which the MathWorks recommends for speed and robustness. Those who favor saving I or J for imaginary number can use different loop counter variable names such as I sample or capital I. Avoid use of both J and capital J in the same scope because they look similar and thus can easily be confused. Use the prefix n for variables representing the number of entities. This notation is taken from mathematics where it is an established convention for indicating the number of items. Use n files, n segments rather than num files, number of segments. A common MATLAB specific variation based on common matrix notation is the use of m rather than n as a prefix for number of rows and as m rows. Follow a consistent convention and pluralization. Avoid having two variables with names differing only by a single final letter. Be especially careful to avoid unintended mixing of singular and plural names. Some programmers make all variable names either singular or plural, but others find that this can be awkward. The recommended practice is to use a prefix like this for a singular variable together with a plural prefix for collection or arrays. For example, singular this point with the plural points, as this point is equal to points, I point. A less common usage for plural is to append a suffix such as array. For example, the singular point with the plural point array as in point array, I point. Use prefix for the current variable. When referring to a single member of a collection, use the other than the this page, pages, I page. Use the suffix no or suffix prefix I for variables representing a single entry number. The no notation is taken from mathematics where it is an established convention for indicating an entity number. Replace table number, employee number with table in number, NO, employee NO. The I prefix effectively make the variable named iterator, which is convenient for indexing. Use I table, I employee as in this employee, employees, I employee. Other suffixes that some programmers use are I, NBR and num. The most important consideration in this guideline is to distinguish clearly between a single entity number and the number of entities. Prefix iterator variables with IJK, etc. The notation is taken from mathematics where it is an established convention for indicating iterators. For I file, one stand file, and many examples of for loops use the variable name I as a loop index. This practice may be suboptimal, particularly if the loop is long, because it misses an opportunity to reinforce the meaning of the loop index. Prefix iterator variable with IJK, etc. for nested loops. The iterator variable should usually be in alphabetical order. Alternatively, some mathematically oriented programmers use a variable name starting with I for rows and J for columns, and independent of that position in the nested loop, especially for nested loop suggestive iterator names are helpful. For I file, 1 is to n file. For a J position, 1 is to n position, etc. Indent. Embed is as, etc. in Boolean names. Use lowercase, lowerCamelCase, and avoid using the word is as a prefix. Replace variable name that start with is avoid if valid range is a valid range is missing data with range is valid, data is missing. In some cases, other words are clear. Borrower can qualify, lender as money. This convention avoids confusion with or shadowing of Boolean function name, which usually start with is in MATLAB software. Avoid negated Boolean variable names. A problem arises when such a name is used in conjunction with the logical negation operator, because this usage results in a double negative. It is not immediately apparent what is meant by the names, such as tilde bar is not found. Replace bar is not found is equal to true with bar found is equal to false, so that we can use not bar found. Use the expected logical names and values. A true or valid condition is usually associated with a positive integer or a logical true. A false or invalid condition is usually associated with 0 or a logical false. To avoid violating expectation, replace misleading and error-prone usage. Valid equals 0 with valid is equal to true. MATLAB associates any non-zero number, even a negative 1, with a true condition. It is generally poor practice to rely on the somewhat confusing behavior. Avoid using a keyword or special value name for variable name. Reserved words have special meaning and can only be used in specific ways. MATLAB can produce cryptic error messages or strange results if any of its reserved words or built-in special values are redefined. Mlint will usually catch an attempt to read any word, keyword, but not if this is done inside an eval statement. Reserved words are listed by the command is keyword. Special values are listed in the MATLAB release documentation. Also, avoid using a variable name that differs from a keyword or special value only by capitalization or a single letter. The code may work, but it can be difficult to read. Thank you.